This is the third 9.6 video. Please pause to check your answers. And now I'll review how to get those answers. For the first problem, we've got a lot of angles to find. I've written in the given information. The first thing that I chose to do was go ahead and fill in the missing arc measurements, like from D to C. I'm able to figure out what D to C is because I know that from EDB is 180 degrees. This is 180. 20 and 50 are taken up. That's 70. 180 minus 70 is 110 degrees. And then on the other side of that semicircle, from E, say, to A all the way to B, that's another 180 degrees, 80 of which is used up. So 180 minus 80 leaves me with 100. Now there's lots of orders that you can do this in, so I'll just go ahead and do the order that I found, but keep in mind it doesn't have to go this way. I noticed angle 3 right away because we've been talking about the angles formed when chords intersect, like chord EB and chord DA. We know there's a formula now where you add the intercepted arcs formed by that intersection. So we've got 50 degrees and 80 degrees, and we average those two to get angle 3, which will be 65 degrees. Something else I noticed right away was angle 8. It's a central angle. Central angles are equal to their intercepted arcs, so since arc CB is 20 degrees, angle 8 is 20 degrees. I noticed angle 1 was an inscribed angle. Angle 1 is intercepting arc BA, which is 80 degrees. So an inscribed angle is 1/2 of its intercepted arc. So that's where the 40 degrees came for angle 1. Let's write that in. I was looking at angle 1 and then saw a triangle. I saw a triangle, well, it's actually, can't name it very well, but let's go like this. This triangle here. Now I don't know two angles of it, but I do know that the exterior angle of a triangle is 65 degrees, and that the remote interior angle should add up to 65. Now I know angle 1 is 40. Angle 9 should give me that sum of 65 with the 40 degrees. 40 degrees plus what will give me 65? And that's 25 degrees. So angle 9 is 25 degrees. Let's see. Next we have measure of angle 6. Now angle 6 is also an inscribed angle. It inscribes D all the way to B. D to B is 110 plus 20. So 110 plus 20, that's 130 degrees. But it's only going to be half of that because it's an inscribed angle. So 110 plus 20 is 130, divide by 2, and we get 65 degrees for angle 6. Measure of angle 7 can now be found because I know two angles in the triangle. 180 minus 65 minus 65 is left 50 degrees. 50 for angle 7. Angle 4. We've got a formula for angle 4. We've got two secants intersecting to form angle 4. So our formula there is that A minus B over 2. Now what's A? A is the larger arc. Now the larger arc that's intercepted by those two secants is from A to C. That's 80 and 20. So the larger arc is 100 minus the smaller arc that's intercepted, which is 50 degrees. Divide by 2, and that gives us 50 degrees, actually. 50 divided by 2 is 50. Or, excuse me, 25. Sorry about that. Let's label that as 25 degrees. On to angle 2. Angle 2. Let's see. We have an inscribed angle. Switch to another color here. Angle 2 is inscribing from A to C, so 80 and 20. But of course, we have to half that because it's an inscribed angle, so 100 divided by 2 gives us 50 degrees. And let's see, I've got angle 10 left over. I'll label angle 2. Angle 10, let's see, where are we? Ah, yes, that rule we learned today, that the measure of an angle formed by a chord and a tangent is half the measure of the intercepted arc. So the intercepted arc is 100 degrees, so it's going to be 1/2 of 100. 100 divided by 2 is 50 degrees. And then finally, angle 5, same thing. We've got a tangent line and a chord AB. So we're going to take half that measurement, half of 80 degrees, which is 40 degrees. Okay. Moving down to our next complicated diagram here. Not quite as many angles, but still. Everything that we're given is just listed in the diagram, so I don't have to write anything in like that. And the first thing that I saw was that angle 1 was a central angle. I knew the arc measurement that it intercepted, so I was able to say that angle 1 equals 110 degrees. I see a semicircle here. I see a semicircle from here to here. That's 180 degrees. I know that 110 is taken up with this chord, so that leaves 70 degrees here. I know 30, I know 50 on the other semicircle. That's 80, so that leaves 100 for this. Maybe not all of those will be necessary to know, but it's nice to know that all your arcs are labeled. Speaking of this 100 degrees, though, we were just working with that rule that a tangent intersecting with the chord, so the tangent is here, chord here, we're going to half that amount to find angle 5. Angle 5 is going to be half of that intercepted arc of 100 degrees. Okay. Looks like we could do the same thing with angle 4. Angle 4, let's see, we've got tangent line, pink, chord, which is a special chord, it happens to be a diameter. So 110 and 70, 180 degrees is the chord or the arc measurement, but we're going to half that for angle 4. So angle 4, half of 180 degrees. The intercepted arc is 180 degrees, that's 90 degrees. Let's see. I gotta go back. I gotta do angle 3 here. Angle 3, again, is that rule where you take the average of the intercepted arcs, the A plus B over 2, when two chords intersect. Let's see. One of the arc measurements is from this point all the way to this point. That's 110. The other is 30 degrees over here, so plus 30, divide that by 2. That gives us 140 divided by 2, or 70 degrees. If I know that 3 is 70 degrees, I can easily figure out that 7 is 110 degrees just because of the straight angle. And I also know that this triangle, or this straight angle, should give me a 70-degree angle. And now I'm looking back at 110. That's an exterior angle of this yellow triangle. Okay. We know that the exterior angle of a triangle is the sum of the two remote interior angles. So I've got 70 degrees plus angle 6 should give me 110. So that's 110 minus 70 degrees, or 40 degrees for angle 6. And I think it looks like the only thing I'm missing is angle 2. Now angle 2 is all the way outside of the circle. It's formed by two secants. So we're going to use that a minus b over 2 formula. A, of course, being the larger arc that's intercepted. Goodness, I'm running out of colors here. We'll try yellow again. The larger arc that is intercepted by the secants making angle 2 is here. Okay. 110 degrees, we've decided. And let's see, the smaller arc, we'll continue with yellow, that is being intercepted, is 50 degrees. And divide that by 2. That gives us 30 degrees. So let's just check. 1, 2, 3, 4, 5, 6, and 7. We've got it. End of the video.